Okay, hi Year 12. Today we're going to be looking at 6C, applications of differentiation. There's a few little points up here for you to recall, and throughout the exercise 6C you'll need to use a lot of those. The yellow one here that I've highlighted is the one that we're primarily going to be using today, the equation of a formula. It's also called the gradient point formula. So let's go down to example number 1 below here, and what it wants us to do is to find the equation of the tangent to y equals 2 sine of x at the point P, where x is equal to pi over 6. And that pi over 6 is in radians there. So we'll need to make sure we're dealing with that. Okay, so the two main things that I've got here are highlighted in blue. We're finding the equation, and it's the equation of the tangent. So we know that our tangent we deal with when we take our first derivative, and when we do that we get our gradient of the tangent. So we're going to need to do that. We're going to pop it into the equation formula, but in order to do that, we need the matching point for x as point P. We need y. So let's find that first. We know x is pi over 6. Let's pop that value into our y to find out what it is here. So y is 2 sine pi over 6. And I'm going to convert that pi over 6 into degrees, because on our HCC formula sheet, our special triangles are in degrees, and we generally feel a little bit more comfortable working with those. So I can either just think of replacing my pi there with 180, and I'm going to divide 180 by 6 and get 30. But basically what we're doing is saying pi over 6, to change to degrees, I'd multiply by 180 over pi. The pi's would cancel, and I'm going to get 180 over 6, which is 30 degrees. So my y is 2 sine of 30, and you're going to pop over to your special triangles, which I have over here, and you'll have on your formula sheet or the back wall of the room. We've got sine of 30, which is opposite on hypotenuse, which is 1/2. So we end up with 2 times a half, which is 1. So we now have our point P, which is pi over 6 and 1. What we need to do is now find our gradient of that tangent, our m. So m is our first derivative. We're going to differentiate y equals 2 sine of x, and we're going to get 2 cos of x. I'm going to pop that down there. But we need to find that at the point x is pi over 6. So I've popped that pi over 6 in where that x is, and I've got 2 cos of pi over 6. So from just above, we know that pi over 6 is equal to 30 degrees if we were to change it from radians to degrees. Now, we can, again, find an exact value for the cos 30 part. So I don't want you finding any decimals. I want exact values. So cos of 30, second special triangle down here, what we're going to do is adjacent on hypotenuse with our 30 degrees, which is root 3 over 2. So we've got 2 times, and we're replacing our cos 30 with root 3 over 2. The 2's cancel, and we get root 3, and that's our gradient of the tangent. So we now have our gradient and our point, and we can pop that in the gradient point formula, which is y minus y1 is equal to mx minus x1. When we pop those values in, what we end up with is y minus 1. There's our 1, it's our y value, is equal to our m, which was root 3, x minus pi over 6. What I did was just multiply out the brackets. So I get y minus 1 equals root 3x minus, what have we got? Root 3 pi over 6. You could leave it like that. You may decide you want to go plus 1 to both sides and get this one. Or you might decide also that I don't like that 6 on the bottom, and I'm going to multiply everything out by 6. So there's a few different variations there for that equation, but they're our answers. Now let's have a look at a slightly harder one over here. Okay, number 2. Now number 2 is looking at the same format that we did up above. It's just with a different curve, and it's the tan curve here. So 2a says to find the equation of the tangent to y equals tan 2 of x at the point on the curve where x is pi over 8. So that's step 1, and we're going to do that the same way as we did above. We're looking at the equation of the tangent, so we need to do our first derivative at the point pi over 8. We need to find our matching y value for our x value and pop that into the equation, and that's step 1. So let's do that below. Okay, so I did that finding the y value first. So x is pi over 8, so y is tan 2 of x. I'll pop that pi over 8 in where the x is, so I get tan 2 pi over 8. The 2 and the 8 will cancel, so I get tan of pi over 4. if you change that pi over 4 to degrees, pi over 4 times 180 over pi, the pi's cancel and 180 divided by 4 gives us 45. So tan of 45 on our special triangles, let's have a look. Either 45 will do. Tan of 45, it's tan opposite on adjacent, so it's going to be 1. Okay. So you can see here we've got there for 1. So tan 45 is equal to 1. So our value of our y is 1. Our x is pi over 8, so we've got our point. Now we need to find our first derivative. M is our first derivative, and it's taking the derivative of our y equals tan 2 of x. So we differentiate that function in there, which is 2. The 2 comes out the front, the tan becomes x squared, and we've got 2x. So the 2's come out the front there, the tan has become x squared, and our 2x stays there. It's at the point pi over 8, so we pop that in, that pi over 8 in where that x is in there. So I get 2 times sec, the 2 is times the pi over 8. And remember, when our squared's popped above the sec part of it, it basically is meaning it's the whole of the sec and the value after it all squared. Now the 2 pi over 8 can break down because 2 over 8 is 1 over 4. So I've rewritten that as 2 times sec pi over 4 all squared. Thinking what sec is, okay, sec is 1 over cos. So I've rewritten that as 1 over cos pi over 4, and it's still all squared. Now cos of pi over 4 is 45. Cos of pi over 4, special triangles, sorry, not, there we are, the top triangle up there, is going to be cos of 45, which is 1 over root 2, adjacent on hypotenuse. So I've changed my cos pi over 4 to 1 over root 2. The 2's still out the front, and we're squaring it. We square that. Well, you can pop this in your calculator, this would work, but I'm not going to. I'm going to square my top, which is 1. I'm going to square my bottom, which is a half. And remember, when we're dividing by a fraction, we're multiplying by the reciprocal. So the 2 stays out the front, and this half flips upside down to become 1 times 2 over 1, which is 2. And we end up with 4 as our gradient. So we now have our x and y value and our 4. Jumping over to my next page here, into our gradient point formula. Y minus y1 equals mx minus x1. There's the information that we've found already. Given the pi over 8, we've found the 1 and the 4. I've popped those straight in there. Y minus 1 is 4x minus pi over 4. I've opened my brackets like this. And then I've decided to add 1 to both sides, and that's my equation that I've ended up with. And that was the first thing we needed to find. The second thing we needed to find was the x and y intercepts of this tangent. So that's fairly straightforward. We're looking at where it cuts the x-axis. So when we're looking at where it cuts the x-axis, I'm looking at where this equation, because this is the equation of the tangent, where that cuts the x-axis, and that is where y is equal to 0. So pop 0 in where y is, and I get 0 is equal to 4x minus pi over 2 plus 1. I need to solve for x, so I've moved my pi over 2 to the other side and my 1 to the other side. So I'm going to end up with pi over 2 minus 1 is 4x. And what I'm going to do is I'm going to use algebraic fractions to neaten up my left-hand side and pop my fractions both over 2. So I'll end up with 2 on the bottom, which means I will get pi minus 2 on the top. So it looks like this. And now it's in a much neater form for me to divide both sides by 4. And when I do that, the 4 cancels on the right, and on the end I get pi minus 2 over 8, and that's equal to x. That's the value of where my tangent cuts the x-axis. Now remembering, pi is actually a value. Pi has a number, 3.14, so we could work out approximately what that is, but I'm going to leave it in that exact format. We wanted to find where it cuts the y-axis. It cuts the y-axis when x is 0. So likewise, what I've done, I've popped in a 0 there. I had minus pi over 2 plus 1. And what I've done is I've neatened that up by popping both of my fractions over the same denominator, and I've got 2 minus pi over 2. That was part B. Part C would like us to sketch that, I'm pretty sure. Let's have a look. C is to sketch it. Yep. Now, what I did first is I had a look at what my base tangent and my base graph looked like. So what I did to start with was I looked at y is equal to tan of x, And I thought, well, what does that actually look like? And I drew that shape in here, and that was the same curve as I've got here. But what I did was think about what my asymptotes were in that graph. And I didn't have pi over 4 in there. My asymptotes for tan of x is actually going to be pi over 2, or our first two asymptotes, either side of 0, are plus and minus pi over 2. So this first dotted line here and this other dotted line here are asymptotes were pi over 2 and minus pi over 2. So pi over 2 minus pi over 2 there. But the curve that we wanted to look at is tan 2 of x. So what that actually does is that's going to change where our asymptotes are. So that will actually make our asymptotes become pi over 4 and minus pi over 4. And the reason it does that is our x is becoming 2x. So we're timesing by x. So we need to divide our divide this by 4. So we're going to end up with a 2 times 2 on the bottom line for our asymptotes. So there's a sketch then of tan 2 of x. I'll pop that little line in there. That shows us that it's tan 2 of x. Our asymptotes are in there for tan 2 of x, minus pi on 4 and pi on 4. And I've drawn in our tangent that we've just discovered the equation of. So that's our tangent that we've just worked out. And I've looked, trying to be really careful at drawing that, and looked at where it cuts our axes. So it's got the point where it cuts the y-axis, the point where it cuts the x-axis, and those are the two values that we just found up above, pi minus 2 over 8 and 2 minus pi over 2. So that's a sketch of that tangent. It might take you a little bit longer to do that, but I'd like you to have a go at doing that. And then the next thing, it wants us to find the area of the bright pink part I've got down there. So it's asking us to find the area of the triangle formed by this tangent and the coordinate plane. Now, the coordinate plane, remember, is just our x and y axes. So if we look at what's happening there, finding the area enclosed by our tangent, there's our coordinate plane. So we want this bright pink area, and we want to find the area of that triangle, which is actually fairly simple because we have a right angle in the corner, and we've got vertical and horizontal sides. So we can straight away just think of how we looked in our junior years at finding the area of a triangle. And the area of a triangle was half the base times the height. So I've just quickly sketched that little pink area up here. Again, so there's the origin, 0, 0. Here's the point where it cuts the y-axis at 2 minus pi over 2, and here's where it cuts the x-axis at pi minus 2 over 8. So the distance between 0 and this point where it cuts the x-axis is our base length of the triangle, or one of our sides. And 0 to where it cuts the y-axis, or 2 minus pi over 2, is our height of the triangle. So if we're just going to go half the base times the height, it's half times this number times this number. So I've popped them in there, and we need to just do a little bit of algebra to neaten that up. So what I did is, and I don't know if you can see that, but looking closely at these two brackets here, where it cuts the x and the y axis, my top lines have 2 minus pi and then pi minus 2, which are the same, but with a change of sign. So I have taken out of this one here a minus sign, and so I've still got my half. My minus has come out, and I've made that into pi minus 2 over 2 and pi minus 2 over 8. So now these two tops are the same. So if I multiply everything together, I've got my minus there. My bottom line becomes 2 times 2 times 8, which is 32. And in my top line, I've got pi minus 2 twice. So I've just popped it in as squared. Now, there is a minus sign there, but we actually don't want that minus sign. We could take the absolute value of that and get rid of that minus sign, because that minus is just telling us that the area is below the x-axis. And that's our answer for the area. If you had popped in the distance here as a negative, then you would not have had that minus sign. It would have cancelled out, and it would have been okay anyway. But that's the area below the x-axis. Now, there's a few of these in our exercise today in 6C, and you're also going to have to start thinking about the unit circle and things that we used in year 11 in order to answer a lot of these questions.